Okay, so let's go. Sorry for the slight delay, but this, well, let's see, shouldn't be a too long lesson. So welcome to the fifth lesson of the Automating GIS Processes course. Those who are online, please let me know if there's something weird with my screen sharing or the audio. There was some feedback that the screen might be a bit blurry during the live streaming. I apologize for that, but haven't yet figured out how to optimize for that. Today we have the full lesson will focus on plotting maps, which is of course the main purpose, or often one main outcome of geographic data analysis workflow is to visualize, communicate the results on maps. And when working on computers, we can of course also make interactive maps to be put on websites, and then static maps that you can then put to your thesis or any other output report. So always when plotting maps, it's good to think about the audience and the platform you will publish the map in, and then based on that make the visual choices and choices related to the elements that you will put to the map. So that's the topic for today, and building upon everything we have learned so far. And then we have one more topic to cover next week, which is well, my favorite topic, OpenStreetMap, how to fetch OpenStreetMap data using Python, and then how to do network analysis. And then the last lesson will be about recapping the contents, and we have some extra materials for self-study. So based on the feedback so far, students have been asking for more stuff related to QGIS. So there you have it now. I have uploaded already these extra materials. So content from last year, completely created by Tatu, who gave that lesson last year. And you have also the lesson video by Tatu Leppämäki. So we won't have this lesson live this year. It's not part of the course requirements, but feel free to go through these materials on your own time. So in the lessons, I will now then focus on those things that are kind of central to achieving the main learning goals. So the basics of plotting for today's lesson. Let's see still if there were any questions about last week. No questions, at least at this point. Helsinki students, feel free to continue asking questions on Slack. There have been good discussions this week, and we will, for example, start this lesson by reprojecting data, which is a topic that comes up whenever working with spatial data and putting different layers on top of each other, which is also the point when plotting maps and multiple map layers. All right, so let's get started then without further delays with lesson 5. So today we will cover building upon our existing Matplotlib plotting skills, and we have already also plotted in GeoPandas simple exploratory maps. So we will focus on that, how we can improve the quality of our static maps, make them visually appealing and informative in the first part of the lesson, and then the second part of the lesson focuses on interactive maps, and there we will use a package called Folium that will then help us create maps in Leaflet, which is a JavaScript library. So without any JavaScript skills, using our Python skills, we can then produce interactive leaflet maps based on our Pandas and GeoPandas data frames. And then there's an additional section, kind of a case study with employment rate data from Finland, and we will go through that if we have time at the end of this lesson. So then students who are online, I will try to monitor the chat, but sometimes it disappears from my screen, so feel free to unmute your mic or raise a hand or somehow get my attention if there's something that's weird. Like last week, somebody noticed a bug or a mistake in the materials, and we were able to then correct that on the fly. Good. So let's start. I hope most of you who are now online have managed to launch a Jupyter Lab instance either on your own computer or over at CSC Notebooks. If not, put the red X, otherwise I will proceed in just a moment. So for making maps, we of course need some data, and these data should be available in the data folder. But if you want or need, or later on if this data folder is not available, we have also a zip file from where you can download data for this lesson. But for now, data should be available in the lesson instance, so we can proceed straight away. So we have some familiar data sets from the Helsinki region. So we have travel times to the railway station readily as a shapefile. So the travel time matrix often comes as these text files, and then you need to join them to this grid shapefile. But here we have the data ready, so we can proceed directly to plotting, and then there's some other layers we can plot on top of that layer. So let's start by reading in the data. And this is something we already know from before. So using GeoPandas, at this point, we also then import other packages that we will use later on in the notebook. But using GeoPandas from these defined file paths, so we use a relative file path from the data folder. We want to read in these three shapefiles to three variables: grid, roads, and metro. So you can see that we have the travel time matrix goes into the grid, and then we have a file for roads and then file for metro line based on the file names at least. So read those in. If there's no errors, things should be fine. So let's, again, first thing after reading in data is to check a bit what do they contain, and verify that we actually imported them correctly. So let's print out their coordinate reference systems. A bit of recap. Grid, CRS. So these GeoPandas geodata frames have this CRS attribute, which contains information about the coordinate reference system. We are in the Helsinki region in Finland, where this EPSG 3067 is quite common CRS. And if you print this object, you get a shorter definition. So EPSG 3067. That seems correct. Then we can add roads CRS. That's something else. We haven't encountered that before. And then Control-C, Control-V, and I modify. So during this lesson, we will do a lot of copy pasting. So in case you are not familiar with the shortcuts, Control-C, Control-V, now is the time to start using those. So based on this, we can see that these roads and metro are not in the same coordinate reference system as our grid. So by default, we cannot just plot them into the same figure without reprojecting, because they are in a different coordinate space. And what is this 2392? Let's check that. So this CRS object let's see actually if it works like this. I'm starting to improvise. Yes, so if you have the CRS object dot name, so you can see, you can get the name of this coordinate reference system, and in this case it's the KKJ Finland zone 2. So this is, those who have studied geography in Finland should be familiar with these KKJ koordinaatisto. So it's an old, Finland used to be divided in kind of 3 zones, 1, 2, 3, according to the east-west location, but this coordinate reference system is no longer supported. But it might be sometimes still that you get some old data in these old localized coordinate reference systems. So that's why I wanted to keep the example in. So let's verify that also for the others. I put the print statement and then Control-C, Control-V, Control-V, and start modifying. It's not in a systematic order, but well, roads, I'll do it like this. Metro, sorry, grid. There we go. So that verifies the thing and just gives us further information about the CRS. So again, it's good not to blindly just, oh, it's in different coordinate reference systems. Let's stop and really understand what is the definition in there, and then we can proceed to reprojecting. So if then there are some problems later on, we might have to look a bit more in detail in these CRS definitions. But in this case, just as a recap, this is something you probably had to do also in the last exercise. So we want to harmonize the coordinate reference systems for plotting the layers on top of each other, or if we would be doing spatial analysis. And in this case, we have these 2 old layers in the old CRS, and then this 1 layer in this commonly used one. So let's project those 2 old ones according to the definition of the new one. So kind of on the fly, take the definition from the other layer. And how to do that? Let's replacing the values from these layers, then to CRS. So at this point, the layer has a CRS definition, and then to CRS of the grid. Okay, and then again, I copy paste the same syntax for metro. So even without plotting these data, we could imagine that these are lines, and then the grid is a polygon layer. That should be fine. And then we can check what we did. Looks good. And maybe grid CRS. That's true. This is maybe not recommended by PEP, but you can kind of quickly check that all of the 3 are now in the same CRS, which then happens to be this ETRS 89 Finland coordinate reference system, which would then probably match other additional data sources. Great, so that was a quick recap on coordinate reference systems, reading in data. And now I will stop speaking for a little while and let you think, let's say maybe 5 even to 10 minutes. So you should now plot these data. So make a visualization and plot first the grid. So we assume to see this kind of surface of the travel times. So there are these travel time values. You are already familiar with the dataset based on the exercises from last week's. So plot first the grid as the kind of bottommost layer using quantized classification scheme. And then on into the same figure, plot the roads and metro, maybe using some color. So you can, of course, sneak peek from the websites for the correct syntax, but I would want to challenge you who are now watching this live or even watching later on YouTube, maybe pause the video and based on your skills so far, try to plot the 3 layers into the same figure object. And then here are some additional hints. I will mute my mic, maybe get a coffee, and then once you're done, doesn't have to be a super fancy map, put the green check mark, and I will check in 5 minutes. Maybe we'll still give you a bit more time. So let's start now refreshing our memory about plotting maps, and then based on that, we can then start making the maps even better or adjusting then the details. So plot, plot, plot. Okay, I will slowly start filling this in, but I hope you got a moment to think about it on your own. So if I get the task of plotting first the grid, so let's start from there. Just grid plot, sorry, scroll up a bit. Let's see what that produces. So we get, it's the polygon layer, it's the travel time matrix covering the whole Helsinki region. And by default, these plots become blue. So we have these polygons and the polygon is blue and so on and so forth. When plotting with GeoPandas, we can define a column based on which the classification will be then done. I don't know if it was actually so well instructed in here, but of course there then we need to choose. We have so many columns that we need to choose one of these columns. Maybe I'll just, for those who are new to this data set. So we have these different columns that represent travel times and travel distances from each grid square to one of these grid squares, which is the Helsinki railway station. Okay. So based on that, I think in the lesson materials, we have car travel time. So car rush hour travel times. Let's see what that gives us. So if you just define one column in a GeoPandas, which has some data in it, so it gives you some kind of probably a linear default visualization. That's great. We can start adjusting things. We can control the color map. It's small, capital S spectral, for example. I think we should have a link to the Matplotlib documentation for different color maps. So depending on the phenomenon you're visualizing, you might want to have this hot spot, cold spot color scheme, or just a gradually darkening color scheme, or then discrete color scheme if you if the values are not linear but categorical. So do think about the phenomenon you're trying to visualize, and also color blindness and all these different things. Then we were asking to plot using the quantiles classification scheme. So this now comes from map classify that we covered more in detail during lesson 4. Scheme small q quantiles. What does that do? So by default, this quantiles gives us, so it takes the distribution of the data and tries to create classes that have equal amount of data. By default, 5 classes, but then using this K parameter that we learned last week. So this is all still recap. Oops. We can then increase the values because the travel times, logically, they kind of graduate. It's a there's no abrupt changes. Of course, there are these geographic patterns, but basically it's a kind of a surface. So we can have this classification, but still with discrete values, but so that the colors change quite smoothly. It's not perfect with this, but quite okay. And well, yeah, then there's this alpha parameter that you might not have had in there, but with this, especially when plotting multiple layers in the same figure, you can then add transparency. Oops. What's wrong with that? Aplaha. I might be dyslexic, but that's fine. There we go. You can't really see it there, but especially if you're then plotting different layers. So it gives a bit softer thing. So yes, we have now managed to plot the grid, but how about the other layers? So if I now do roads plot, what do I get? So often if you don't know how, just try things and then incrementally make things better. So as you can see, if I plot the first geodata frame, plot the second geodata frame, I get 2 plots. So they are in the same coordinate space, but not in the same figure. And then how to put them to the same figure from here. Don't yet change your syntax if you did something else. You could do something like this. So there is this AX, which refers to the subplot object. So that is an optional argument when plotting geodata frames. So we could do, let's not call it map, but my map, because map seems to be a reserved word. So my map, something like this. So now we kind of store this figure object in here and refer back to it when plotting the new layer. And here the order matters. Python always runs things from top to the bottom, unless in a loop. So this gets plotted first, and then on top on the same figure, we can plot the roads. And then, oops, maybe rather quickly, let's adjust the roads a bit. So with line objects, you can change the color, gray, and then the line width. So make it less bulky maybe. And all these you can experiment. There's no, I'm not the kind of super expert cartographer, but there are some things you can adjust, like make them blend in a bit more, or not to look pop up too much if the roads are not the main topic of this map. They are there to provide some contextual information. And then same way, metro plot AX my map. We could do color red and then line width something. Let's try that one. As you can see, this is a very old data set because our metro line nowadays goes until Espoo, so to the west. Excellent. So something like this we were asking you to produce. And let's now improve this together a bit. So this is okay, but then if we would want to, for example, control the figure object, the size and everything, so then we want to start using or importing matplotlib tools. So let's create one subplot and then control figure size here. So I will do, we have done this before many times, but it's a bit, I don't know, abstract or not so easy to understand this figure and subplot objects. But often it's a good practice to take this matplotlib pyplot that we imported at the top of the notebook, and then in there you could make these panel multi-panel plots, but in here we are doing just one plot, so we can just define the figure size. It's in inches, I think. So something like that might produce a bit bigger map. That would be nicer, maximize the space. And then now we create the figure and axis. So then we need to modify so that we plot all of these layers into this subplot. It's customary to, if we have one subplot, it's often AX. If it's multiple, it can be axes. And then axis 1, 2, 3, and so on using the indices. There we go. So this is the very, very basics of plotting spatial data layers into one figure using Python, GeoPandas, Matplotlib. You can control the figure size here. And of course, always then remember to comment your code to also afterwards. Remember what you were doing. There we go. And then, well, one thing, if we create the figure, we might want to then save. Very basic thing, save the figure. So let's create some file path. Static map. PNG is often a good option. You can also write SVG files, which you can then import to some vector graphics software, such as Inkscape, which is open source, then to continue modifying the map manually. But here, of course, we are creating maps that we want to automatically produce. For example, with the travel time matrix data, we have these 13,000 grid files. So we could, putting this script into a loop, we could plot 13,000 maps, everything systematic. So PLT save fig. Now that we have to do this in the same code cell as where we are plotting the thing in order to plot the current active figure object. So out FP, and then we can also influence the how precise the output figure is. If you're creating plots for a scientific publication, they often require specific quality. And then when you did that, you can find the figure file in the root directory now that we saved it in there. As a figure object, it's rather big actually over there. And then you could put it to your thesis or wherever, download it. Excellent. So yeah, I think that's clear. Of course, I've been doing these now quite a lot, so I remember all of this by heart. If there's been a gap, then always have to check the specific syntax. And sometimes then it might be useful to create a specific function that handles the plotting. Depends on the case. So then you could, for example, create a function for plotting travel time matrices where you can pass the column and some other number of classes or classification scheme that you can then reuse in other parts of your code. Great. Excellent. If there's no questions about this, maybe if you want to comment to the chat box, if there was something that you were not able to do, was it this subplot thing or something that was difficult with plotting the layers into the same figure, or is this all super clear, just about remembering what to write and where? A side note, now that we are here, I've been going through the final assignment, so it's good PEP practice when you're using some function and assigning the parameter values, not to leave empty spaces in here. So be systematic in the formatting of the code, also in these kinds of things. Just a quick side note. Okay, no comments. I will then proceed. So with static maps, adding a legend in Python, it's easy and it's also a bit tricky. So this is now a new section that wasn't there in last year's materials, but I just added it because it often causes headache in the exercise, and there's a bit of tinkering you need to do. So let's now start recycling our code. I will do so that I copy from here the figure and axis and then plotting the grid, Control-C, and put it in here, Control-V. And I will actually then take out this classification scheme thing. So let's just start from here. When we plot without using the map classify classifications, we use the kind of default, some kind of default. Maybe make it a bit smaller to see something. Using the default settings, you can see here these dark areas are no data, which we haven't removed. We should remove them for a proper map. We can for now ignore them. So the simplest way to add a legend is to add this legend true parameter. And that will give us this kind of, I don't remember the official name, but this kind of color map object, which then shows the values or the range of the values. So we can roughly see that 70 is in there. It's the highest value, and then the data starts from 0. Of course, now the question is that what's the unit and so on, and that we know from the data that these are now minutes representing travel time by car to the railway station. So of course, we might want to add that information to our legend. So when plotting using GeoPandas, this was updated, I think, in GeoPandas 0.6. There is this handy thing when you're adding this legend equals true. So you can also pass these kind of legend keywords as a dictionary. And first and foremost, you can, using this, define a label for the legend. So in a dictionary, label, and then the value for the label. So let's add that one. And now that we are getting so many parameters, sometimes it's good to format the code so that after each comma, you create a new line. So then it's easier to change and adjust the code later on. So I will add this legend KWDS, yes, dictionary. So curly brackets, then as character string label. So this will pass the parameter to the actual thing, which is matplotlib legend object. So as the label, there will be what are we plotting? Travel time in minutes, right? And rerun this cell. So yes, now we get a label. So that's already kind of good enough. For this one, we could of course still improve this map in terms of cartographic choices, and definitely first thing would be to remove the no data values. Another side note, when formatting your code like this, it's quite easy then to, if you have the ending bracket on a different line, I can easily comment out some of these parameters, rerun the code, and then comment it back out and then rerun the code. So like this, then it's easy to quickly check what is the effect of the transparency, for example, without actually deleting parts of the code. Okay, so that's a very quick introduction to this kind of color bar legend. And from here, you can then, for example, see if it would make more sense to have it at the bottom. You can change the orientation from using these legend keywords. But things are not that simple. So let's again do some copy pasting. I will copy paste everything from here. paste it in here. And now I'll remove all of these and actually take back I have some problems with indentation scheme. So classification scheme, quantiles. Then we had the k equals 9. Let's see first what that produces. No errors. So we have this now, this classified map. And if now we do legend, oops, true. So we get this kind of discrete classes based on the classification, quantiles classification. So we can actually see the value ranges, which is great. But at the same time, as you can see, that the legend covers part of our map, which is suboptimal. So for a very quick, like exploratory map, it's fine, or even for the course submissions, don't stress about it too much, but there is a way to modify this. However, we cannot use these if you now try to do this legend keywords. Just to demonstrate, I assume we are getting an error. Yes. So unexpected keyword. So I have to admit that I don't really know the technical reason for this, but in short, in plain English, this legend object that we get via map classify is a bit different that we get by default. And thus we need to kind of change its properties a bit differently. But it is kind of an object, legend object in Matplotlib. And for that, there are tools to access it. So this is now a bit complicated syntax. I'll try to give you enough time to write it down. So from this subplot of object we can access the legend. And then for that legend object, we can set set BB box, bounding box to anchor, all small letters, underscores in between. So this will kind of set the location of the legend in the figure, in the kind of coordinate space of the figure. And for this, I'll start with, so it has to be a tuple. Can read more about the documentation of this. But if I do like this, nothing yet changes. So this position is 1.1. So I want to then move the, at least I have done this so far through trial and error. Maybe next year I'll have deeper understanding of this and can motivate the choices a bit better. But if you then move kind of on the left, right dimension, the bounding box location, we can then move it a bit further, maybe let's add a bit more. There we go. Maybe I would do 35 for this one. So it depends on the size of your figure. I think this is now in, yeah, actually, yeah. Anyway, so it depends on the size of the figure object where you need to then position it. So I suggest in here the approach of trial and error for finding the optimal location. Of course, we can then also remove the frame from here, in which case the legend could be a bit closer. But this is, in a way, good enough. There's a question. Okay, I'll check this question a bit later. I need to read it with a bit more concentration, but let's wrap this part up. So let's still add the title for the legend. So there was a very good question about these types of legends in the chat, and I will read that during the break. But then for the subplot legend object, we can also set title. And the title was travel time and then unit is minutes. There we go. So I often do so that I kind of automate it as far as necessary in a way in Python. And if I'm only producing one map, I might then take it to, for example, Inkscape and modify it further. I could imagine that then there's a way to remove the frame, so on and so forth for this object. But already these two approaches get you quite far for getting a nice legend that's not on top of the figure itself. All right, so there was one question to add all legend. Brian, I don't get your question. Maybe you can reframe it. So for sure there are more questions about legends, and I will then do my best to answer those either at the end of the class or then after the class. Okay, good. Still to wrap up this first part, so especially in the exercise this week, the first task is to plot a static map. So there are these technical aspects, but then of course, good to pay attention to the cartographic choices. So when I started studying geography, we had this geographers or cartographers checklist, which included a north arrow and a scale bar and a legend and so on. So we could now debate if this type of map really requires a north arrow. Maybe yes, maybe not. Of course, if you're plotting things that are by default not having north at the top of the figure, maybe then yes. Scale bar would be nice, and that you could of course plot using just plotting a line of specific length or then some figure on top of there, but legend definitely, title maybe yes. But then also this, like in terms of scale and contextual information, one way with these digital maps is that we can add base maps from external sources, and then we can maybe avoid some of these or enrich the map a bit further. So that's then the next topic related to the static maps, and I think we have time to go through that before then having a break and moving forward to interactive maps. All right, but yeah, let's definitely return to the legend questions. Okay, so how to add then base maps? So kind of contextual information using a base map, either a satellite image or then, like, for example, OpenStreetMap data to accompany then your spatial layer. In this first example, we had this kind of contextual spatial information in the form of simplified lines. That might be a good choice in some cases, and then in some cases you could just quickly add a base map. But not always. I want to emphasize that base map doesn't always add value to the map. But yeah, let's see how we can do it. We are here reading in the grid again, which is unnecessary, but let's still do it in order to have a closer look at it again. And we are, in addition to the familiar packages, we are importing a package called Contextly, which is a handy package then to add these base maps from different providers to Python plots that represent maps. And important thing here is that then often these base maps are given in this web Mercator projection. So sometimes you might end up with funny base maps or then totally weird looking figures if the coordinate reference systems are not correctly defined. Maybe I will still open this. So this takes us to GitHub. So from here you can then read more details of the available providers, and we will use these basically the same providers then later on when using Folium. So for example, OpenStreetMap is often a good basic base map. You might then want to have this more geographic base maps that emphasize geographic features or then administrative regions. Black background, gray, more white background, and so on and so forth. Often the simpler, the better. Cool. So again, before proceeding, let's check our input coordinate reference system. And it is still this EPSG 3067. And as mentioned, we will want the layer in this web Mercator projection in order to then match our geometries with the background tiles. So we could then either replace the grid, or then now we will start, or at least I will create a new variable called data. And then using the EPSG code, so 3857, we can pre-project our grid layer to this web Mercator. And let's print data.crs and then still data.head. You can see, you might remember that we had values that started with 3 and 6 in our previous coordinate space. And now we can verify that the actual geometries have also been modified so that they are in this web Mercator coordinate reference system. So we have slightly different geometry definitions than in our geodata frame. Everything looks good. Yep, so this was the old one and this is now the new one. So these steps, if you're having problems with plotting layers on top of each other or doing overlay analysis, always check the CRS after reading the data, after reprojecting data, before doing the overlay analysis. Print CRS, print CRS. Great, so let's create another kind of single subplot object. Make it big. So this needs to be a tuple. Fig, just an empty figure object to start with. And then let's plot the data. Data.plot AX equals AX, and then column, let's change to public transport, which is preferable means of transport with a mask nowadays. CMap can be something, where we can change that later. So same thing, still a static map, default visualization. Now that we plot it a bit bigger, we can see the kind of grid lines. We can actually do line width 0 to reduce extra clutter in there. So maybe that helped. I don't know. Let's do the classification scheme. Quantiles, enough number of classes, so 9 breakpoints. Okay. There we go. This is a bit, the colors are maybe a bit exotic, looks like a poisonous snake. So in the lesson materials, we're recommending this color map, which goes like this. So as a character string, this red, yellow, blue, so RDYLBU. Okay, so something like this we have often done. Now I will on the fly remove no values data. see if I get it right. PTRT. You don't have to do this, but is it subset? Checking if I remember this correctly. I need to, sorry, data, LNA. This now takes a bit of time, but is it like this? Well, if somebody remembers on the fly the syntax for filling no data values like this, I could also do, I'll do like this. So data log, sorry for improvising, so data, then this one. Yes, okay. So that's one way of getting rid of the no data values, because in this data they are coded as -1. Would be more stylish to use the fill them or recognize them as no data values. So then actually using GeoPandas, we could even mark those with specific color. We don't have it in our materials, but you can check the GeoPandas documentation for doing something like this for missing values in the data that have to be then as no data in the data frame. Okay, a bit of a sidetrack. Let's get back to plotting the background map now that we have removed the grid squares that don't have any data in them. So finally, the syntax is quite simple. Add basemap, CTX, add basemap, and then here, so that's the function, and then as a parameter we give the subplot. So to that subplot add basemap. So this will add the default basemap. Let's see how it looks like. It might take a couple of moments to plot. Yes. Thanks. So Tony shared more stylish code to first replace -1 with NaN and then drop Na, for example, like that. You could get rid of them. So I got my map from the kind of credits. You can see that it's by Stamen Design. So based on OpenStreetMap data, styled by Stamen, Creative Commons license. So this is Stamen terrain style, if I'm not totally wrong. You can see it in the background, but now it's a bit stupid still, because we have this kind of, our polygon layers are covering the background map. Of course, it gives us the location of the Gulf of Finland, but we could then add this alpha. 0.6, for example, so alpha ranges from 0, total transparency, to 1, no transparency at all. So I don't know if this is yet perfect, but then if there's some distinct features in the background map, you can then reduce transparency in the polygon layer to get those visible. So here's a very basic way of adding this contextual spatial information using a background map. Yeah, I'll speed up a bit. Won't take too long before the break, but I will show a couple of ways to then adjust the base map and adjust our static map. So there are many more available background map tiles in addition to this Stamen terrain. And how to know what's available, you can go to contextually documentation or then do CTX providers. That's a dictionary, and if you print it, take it like this, you can get the values or the keys. So all of these are providers available. So there's, for example, Esri here, maps, OpenStreetMap. There we go. Different Stamen, which is then based on. So many of these are based on OpenStreetMap. Actually, I'm curious. Get a bit more information on this. NLS. Oh, well, never mind. You can then see more closely the documentation for the different ones, but often good sources are OpenStreetMap, Esri here, or then these Stamen styles. And then, for example, for OpenStreetMap, capital first letters keys, you can then see, I have providers, plural. So for OpenStreetMap, you have then these different versions of the OpenStreetMap data visualization. For example, humanitarian OpenStreetMap visualization, MapNIC is the kind of default one, and then there's some others. So these might be available. If you go to openstreetmap.org, you can visualize these different versions in here. In QGIS, you can have these background layers available. And here now then in Python, we can plot those together with our maps. So let's copy paste again. I scroll up. Let's take this, this map. We can remove the no data values, remove, well, from there, like this. So then to modify this add base map section, we have source. We can set it as CTX providers OpenStreetMap and then MapNIC from here. And as it comes over the internet, it might take a couple of moments, but not too long. Okay, so now compared to the previous map, you can see that, well, it's the same source data, but the style is now the basic default OpenStreetMap. And often a reminder, good practice when plotting maps, good to have the credits in there. We will soon see how to add credits also for the data we are plotting. So we have the background image, and then we have the travel time matrix data set in this map figure. So good practice to give credit to the data sources whenever plotting and publishing data. Let's still do a couple of more steps. So at least I have on the clipboard the same syntax. So let's take that one. Oops. Or maybe you can go and copy paste this one from the previous cell. So let's add one step, subset data. So now using this lock that I already quickly used for getting rid of the no data values. So let's take from the public transport travel time column. Well, there it actually was. We can now only take values that are less than 15 minutes. And then if I store it to the variable subset, I need to modify from here. So subset plot, and everything else is the same. Maybe I can reduce the number of classes, as we will now have only those grid squares with 15 minutes travel time to the railway station. And again, it takes just a couple of moments to plot it. So this now, as we reduce the data to values less than 15, logically, they are close to the railway station, which we can now then see here, thanks to the OpenStreetMap data. And then values closer in terms of travel time with public transport, or these are probably just walking times in here, are with red. And then you can see that from Kulosaari Metro, you can get to the railway station in 15 minutes, also Herttoniemi, Pasila, and then so on. So this is one way of zooming in your map by modifying actually the data. And as we reduce the data, then the plot gets zoomed in. So that's one way of zooming in. But now here the kind of background image is in the default, kind of in the default zoom level. I will just add the next step in here in the interest of time. So if you add zoom, for example, 11, so this will now reduce the level of detail in the background map. So in here, of course, we would want to have the more precise, kind of the previous version, so the more precise background map. But if you're super zoomed out, then you might be fine with less detail in the background map. So if I now take this out and compare, so you can see that even the color of the road changes. So in the tile service, there are these different kind of, well, resolution levels or precision levels that can be then rendered on the background depending on the desired zoom level. So that there was a slot for that in here, but let's now skip it. I'll still show this alternative way of zooming in the data if you don't want to modify the input data. And at the same time, we will add these proper credits to the data. So this is now just a character string. Credits, travel time, data by Digital Geography Lab. It could be, is it 2015? And then map data, OpenStreetMap contributors. So whenever using OpenStreetMap as background or in your analysis, do credit the source, and also with any other data. So one more copy paste. I will take this. Well, let's take this from the previous cell. You can copy paste everything and start modifying under the credits. So let's get rid of the subset, plot the data again. We can increase the number of classes again. And then this requires a bit of attention. But after creating the figure, plot the data, add the base map, we can crop the figure. So this now happens at the level of the subplot. So AX set X lim. So this would work with any type of plot. We just we plot the data, and then afterwards we just reduce the axes according to some coordinate information. And this needs to be in the coordinate space of our data. I will write this in 276, and then we have 4 zeros, comma 280, 4 zeros. So this depends on the geographic location where your data is in the Mercator, Web Mercator projection then. And then ylim, same for the y-axis, the values just change. So 843 and 4 zeros, and then 847. Min, max for the x and y axis. Okay, so in this way you can plot the original data. You don't have to modify it. You can then just kind of zoom in to a specific region to focus focus the map. And what did we forget? We forgot the credits. So that we need to add to the contextually syntax. So attribution credits. Okay, so there you go. So then you can customize this credit. Of course, you can have the credits in the caption, but it's good practice to have it in the figure object so that the credits don't get lost. Okay, so I would say in this week's exercise, problem 1, task is to create a static map. You can use the travel time data, but maybe add a layer of analysis in there, and then at least have proper credits. Think about adding a legend in here. Think about if you want the base map, or if you rather have some contextual spatial layers in there to convey the information. And in this case, it would be travel times to railway station. Great. I'll stop here so that we can have a break and maybe switch back to the website to scroll through the rest of it. Can maybe return to these map tiles also later and show how you can add these map tiles to QGIS using a Python script from here. So then in addition to this contextually source providers dot something based on the available list, you can then also add maps from different tile services using these XYZ tiles, for example, from CartoDB or other providers. So this next part explains a bit what the syntax is about. So using these same kind of references, you can add base maps in different applications. And then here, the difference is that you need to know a bit about the source. So the name of the layer in that provider. And then when adding that particular base map from the XYZ tile service, then you have to have this URL specified and then pass that as the source instead of these inbuilt providers. And then you can add also the other features in there. So if you find some provider outside the default ones, you can probably then add it like this, but at least these CartoDB maps are available. And this part then just shows how to change the default one to this dark background. Okay, so yeah, that was a thorough package of static map plotting. Let's take a break and then we will continue with interactive maps.